So we are going to see some basic MCQs regarding cement and properties of cement concrete. So the first question is, what is the primary component of cement? And out of the options sand, gravel, clinker and lime, the correct answer is clinker. Clinker is a nodular material produced by heating a mixture of limestone, clay and other materials, basically making it as the primary component of cement. Next question, what is the role of gypsum that is played by it in cement production? See, the gypsum has its role to enhance, to improve the early strength. Okay, it is added to regulate the setting time of cement and improve its early strength development. Then the temperature range at which clinker is formed in cement production. The range is, the correct answer is 1100 to 1300 degrees Celsius. The explanation being, clinker is formed by heating the raw material to temperature within the range of 1100 to 1300 degrees Celsius in the cement kiln. Question 4. Which raw material provides the main source of calcium in cement production? Out of the options clay, sand, limestone or iron ore, the answer is limestone. It is the essential main source of calcium. Then primary function of the kiln in cement manufacturing. The kiln forms the clinker in the cement manufacturing. Then what is the typical gypsum content in cement? It is given in the range of 5 to 8%. Okay, it helps to control the setting time of cement. Then question 7, which element contributes to the grey color of most cement? The typical significant grey color of cement is given out by iron. Presence of iron contributes the grey color to cement. Then which of the following is not a type of cement? Portland, blended, sulphate or ceramic. Ceramic cement doesn't exist. We have Portland cement, then we have blended cement, then we have sulphate cement, but we don't have any kind of ceramic cement. Then which of the cement is produced by grinding clinker with a small amount of calcium sulphate? The answer is OPC, that is ordinary Portland cement. Then what is the purpose of adding fly ash to cement? The answer is, the correct answer here goes like, it enhances the durability of concrete over time. This is the reason of adding fly ash. Then which compound in cement contributes to the early strength development? The answer is tricalcium silicate, that is C3S. Then which of the following is not a secondary raw material used in cement production? The answer is sand. What is the purpose of adding slag to cement? See, slag is added to reduce the heat generated during hydration process. That's why the correct answer is to reduce the heat of hydration. Then which kind of cement is suitable for use in marine environment? See, the answer is sulphate resistant cement. Okay, wherever chemicals and salineness is exposed to the structure, we are going to use sulphate resistant cement. Then which component of cement is responsible for setting and hardening through a chemical reaction of water? The answer is clinker. Clinker reacts with water to form compound that set and harden the cement. The chemical reaction is initiated from clinker. Now what is the purpose of adding water to cement? Water is added to activate the hydration process, right? Then which compound in cement contributes to the late strength development? See, the late strength development is initiated, or it is the thing which is carried out by dicalcium silicate. Then what is the purpose of curing in cement and concrete application? Why we carry out curing? See, it is done to maintain adequate moisture level for proper hydration and strength development in cement and concrete. So the answer is to ensure hydration and strength gain. Then which type of cement is used for mass concrete construction to reduce heat generation? We are going to use low heat cement for reducing the heat generation whenever we are going for mass concreting, just like dams or some masonry structures are there. Then what is the purpose of adding air-entraining agents to cement? In order to improve the workability, we are going to add air-entraining agents. Then which compound in cement contributes to the color and resistance to sulfate attack? Tetracalcium aluminoferrite or C4AF contributes to color and sulfate resistance in cement. Then which type of cement is known for its high early strength development? The answer is rapid hardening cement. Rapid hardening cement is designed to achieve high early strength. Then what is the function of calcium sulfate, or let's say gypsum, in cement production? Gypsum regulates the setting time of cement. Then which type of cement contains a significant amount of pozzolanic material? The answer is Portland Pozzolana Cement, that is PPC. It contains pozzolanic material which contributes to improved durability of cement. Then which component in cement provides a source of alumina and iron? Tricalcium aluminate provides a source of alumina and iron in cement. Then which type of cement is produced by intergrinding Portland cement clinker with specific amount of calcium sulfate and pozzolanic material? The correct answer here is Portland Pozzolana Cement, that is PPC. Which type of cement is commonly used in architectural application due to its white color? The answer, obviously, it is going to be white cement, right? It gives the aesthetics to the structure. Then what is the main feature of rapid hardening cement? It gains strength early, right? The early strength gain is the essential property that a rapid hardening cement has, and it is suitable for project requiring early load bearing capacity. Then which type of cement is suitable for use in construction where the risk of sulfate attack is high? Obviously, when we are saying that the risk of sulfate attack is high, risk of chemical attack is high, risk of salineness attack is high, and we are obviously going with sulfate resistant cement. Then what is the distinctive property of low heat cement? It generates, see the name itself it is suggesting, low heat cement generates less heat during hydration and reduces the risk of cracks in large concrete masses. For example, if we are going for a dam construction or a massive construction or any kind of monolithic construction, then we will be going with low initial heat generation cement, which is the low heat cement. Which type of cement is obtained by grinding granulated blast furnace slag with Portland cement clinker? The answer is composite cement. Okay, composite cement is produced by blending or adding two kinds, that is granulated blast furnace slag and Portland cement with clinker. Then what is the primary advantage of using hydrophobic cement? Okay, the word hydrophobic means having phobia of water. That's why the water which will be keeping away from water, or which is going to be hydrophobic or waterproof, it is the hydrophobic cement, right? It has increased water resistance, and that's why it will be used in water bodied structures. Then which type of cement is suitable for use in high temperature environment such as foundries and furnaces? Then we will be going with High-Alumina Cement because it can withstand high temperatures, very high temperatures. Then what is the purpose of using expansive cement? Then to induce controlled expansion, we are going to use expansive cement. It has application in pre-stress and post-tension concrete application. Which type of cement is designed to set and harden underwater? The answer is underwater cement. Whenever we are going for underwater construction, such as bridge piers are there, or any kind of structure which is submerged in water, then we will be using underwater cement because it hardens effectively and it sets properly underwater. And what is the main characteristics of oil well cement? Compatibility with oil-based drilling fluids is the basic or the very property of what, or characteristic of oil well cement. And which kind of cement is used for lining furnaces and kilns due to its high refractory properties? The answer is High-Alumina Cement. We already saw it. It can withstand high temperatures. That's why we are going to use High-Alumina Cement wherever temperatures are very, very high. Then which type of cement is used for application requiring resistance to sulfuric acid attack? See, acid attack, chemical attack, attacks from salinity, attacks from any kind of chemical is there. We use acid resistant cement. Then what is the primary use of masonry cement? See, masonry cement is used for general construction purpose, that is bricklaying or plastering or construction where it is exposed to atmosphere, it is used over there. Which type of cement is used in construction of dams and other massive concrete structures? The answer is composite cement. Okay, because of its heat reducing properties, or we can use low heat cement also here, right? Composite cement has its heat reducing property, and whenever we are going for massive construction such as dams, the heat cracking is a problem. That's why we are going to use either composite cement or low heat cement. Then what is the primary purpose of air-entraining cement? The sole purpose of air-entraining cement is to improve workability and durability of the concrete mix. Then which type of cement is used for the repairing damaged concrete structure? Then we will be using repair cement. Okay, by graniting grouting method, we are going to use repair cement for that. Which type of cement is used for decorative purpose and to achieve various colors in concrete? We are going to use colored cement for aesthetics, for decorative purpose, for that specific appearance. Which kind of cement is used for soil stabilization and ground improvement projects? Soil cement is the answer. It improves the mechanical properties of soil and increases the stability of the soil in which the structure is getting constructed. What is the primary purpose of blended cement? In order to reduce environmental impact, we are going to use the blended cement. Then which type of cement is commonly used for making non-structural concrete products like tiles and pipes? Okay, we are going to use masonry cement for that. What is the primary purpose of white Portland cement? The answer is decorative application. Obviously, it provides good aesthetics and appearance. That's why we are going to use the white Portland cement for that. Which type of cement is used for grouting and anchoring applications? The answer obviously from the option looks like to be the grouting cement. Then which type of cement is used to repair concrete structure subjected to chemical attack and erosion? Obviously, whenever we are saying chemical attack, erosion, salinity attack, either the answer should be acid resistant cement, or whenever we are saying that sulfate attack is there, then we will be using sulfate resisting cement. Then which of the cement is used for underwater construction and repair work? The answer is going to be underwater cement. Then what is the water cement ratio in concrete mix design? Okay, it is the ratio of water content to cement content, right? Whenever we are fluctuating the cement water cement ratio, we are going to fluctuate the workability, the strength and durability of the concrete. Then a low water cement ratio typically results into higher cement. Okay, lower water cement ratio lead to improved cement hydration and increased compressive strength. Then excessive water in a concrete mix can lead to reduced durability. Okay, extra water, less the durability. More will be the workability, but obviously durability is going to be less. Addition of excess water may lead to bleeding and segregation also. What is the primary purpose of using chemical admixture in concrete mixture? Enhancing the workability. Okay, the sole purpose of using chemical admixture in concrete mixture is to improve, is to add on the workability property of concrete. Then the water cement ratio affect which concrete property the most? Then the answer is going to be compressive strength. The water cement ratio fluctuation is going to fluctuate the compressive strength of cement or concrete. Which statement is true regarding the water cement ratio and durability? The answer is lower water cement ratio improves durability. Which factor contributes to increased strength of low water cement ratio of concrete? The answer being improved cement hydration. Okay, a lower water cement ratio promotes better cement hydration, leading to higher strength, that is higher compressive strength. What is the recommended water cement ratio range for most structural concrete application? The range is 0.25 to 0.35. Okay, water to cement content should go in the ratio range of 0.25 to 0.35. Then which type of concrete, which type of water is typically not suitable for concrete production? Obviously, it is going to be seawater. See, potable water has no problem, deionized water has no problem, distilled water will not be containing anything which will be harmful for concrete, but seawater, it consists high salinity, high contents of chloride ion. They are going to cause corrosion of the steel that we are going to, that is, they are going to corrode the reinforcement. What is the maximum allowable chloride ion content in water used for mixing concrete? It should be less than 200 ppm. Okay, maximum we can have it as 200 ppm. Suggestible is what is being suggested is it should be less than 200 ppm. That's why the reason of not using seawater or saline water in concrete making. Why is using excessively hard water not recommended for concrete production? See, obviously it can contain chloride content. That's why it is going to affect the workability, it is going to affect cement hydration, it is going to affect strength, and ultimately it is going to affect the reinforcement that we are going to provide in concrete. Then which factor is of utmost, means highest importance when considering the quality of water for concrete mixing? Then is it going to be color? No. Taste? No. Odor? No. It is going to be pH of water. pH of water is going to decide whether it is being acidic or alkaline, and we don't want any of that range. We don't want acidic water or we don't want alkaline water. We want neutral water, right? Then what is the acceptable pH range of water that is being used for concrete mix? It should be the neutral range, that is 5 to 7, or let's say 6.5 to 8.5. Okay, the range should be neutral one. It should not be acidic like here in the option it is 2 to 4, nor it should be alkaline, that is 8 to 10 or 11 to 14. Then why the presence of organic matter such as oil, grease or undesirable concrete in concrete mixing water? Okay, then it is going to reduce the concrete strength and durability, right? Organic matter interfere with cement hydration, leading to reduced strength and durability, and organic matter is putrescible, means it will go away. It is going to create voids in the concrete where we are using that specific cement. Then which type of water source is typically the best choice for concrete production? See, out of these sources, these are natural sources. Which one? River, then well, then rainwater. And out of that, municipal tap water is controlled. Okay, whatever the contents of water are in there, they are controlled. That's why the pH range will be okay, the chemical contents are going to be okay. That's why the treated water, that is municipal tap water, is used for concrete production. We cannot use river or well or rainwater for that. Then what effect can high sulfate content in the water have on concrete durability? High sulfate content is going to have that increase in sulfate attack risk. Okay, then concrete structure and durability is affected because of sulfate content. That's why we are going to see that sulfate content being high in water going to increase in sulfate attack risk. Which water quality parameter affect the workability of concrete and setting time? Alkalinity affects the setting time and workability of concrete. And what is the primary concern when using water from unknown source for concrete mixing? It doesn't have anything to do with aesthetic property, that is what is the color of water or what is the temperature of water, what is the taste of water. Ultimately the chemical impurities that are present in water are going to affect the concrete mix. That's why the correct answer is chemical impurities in water is the primary concern. Okay. Which water source should be avoided due to the risk of containing harmful substances that affect concrete performance? Okay, industrial wastewater. We can go with potable water, obviously. Municipal tap water is the perfect one. Then well water, if it is being used for drinking purpose, then we can use it for concrete mixing also. Rainwater, if it is not being contaminated, then it's okay. We can once use rainwater, but industrial wastewater has highest content of chemical contents. That's why we are not going to risk our concrete with industrial wastewater. Then how can water cement ratio and water quality contribute to concrete sustainability? The answer is by improving long-term performance and minimizing maintenance. The water cement ratio and water quality contributes to concrete sustainability. Then how does water cement ratio influence the potential for efflorescence in concrete? Lower water cement ratio reduces efflorescence. Okay, efflorescence means giving out some chemicals, giving out some gases or giving out some compound. Okay, lower the water cement ratio is, then migration of soluble salt to surface is decreased. Okay, when we say efflorescence is there, like we have seen in bricks, efflorescence causes the minerals, the salt to come out to the outer surface. If the water content is high, then the chances of salt coming to the surface is high. But if the water content is low, lower water cement ratio have this tendency to reduce the migration of salts or minerals to the surface. Then why it is important? To ensure uniform water distribution in the concrete mixture, to maintain consistent properties. Okay, homogeneity is important, right? That's why uniform water distribution is important. Then what is the role of water in hydration process? Then water activates the cement particle. The activity, that is chemical action, is initiated by the water. That's why it is important for hydration of cement. What effect can what effect can elevate water temperature have on the setting time of concrete? It accelerates the setting time. Okay, water temperature, if it is high, then it can accelerate setting time. How can the temperature of water used for mixing affect the overall concrete performance? See, it can influence setting time, then workability and strength. Okay, if the temperature is high or the temperature is low, it is going to affect these many performances. What is water admixtures in the context of cement and concrete? See, admixtures are the chemicals or material that we add to concrete to enhance the properties, such as workability is there, or early strength gain is there, or delayed setting time is there. That are the roles played by admixtures. Then which type of admixture is commonly used to reduce the water requirements in a concrete mix without affecting workability? Means we don't have to affect workability and we want to reduce the water requirement. Then water reducing admixture or chemicals are used here. Then what is the purpose of using air entering admixture in concrete? See, workability is increased by introducing air bubbles. That's why air entering admixture are used to improve the workability. Then which admixture is used to extend the setting time of concrete, especially in hot weather condition? Retarding admixture is used to slow down, to delay the setting time of concrete. Then what is the primary purpose of using accelerating admixture in concrete? See, to enhance the early strength development, we are going to use accelerating admixtures. Then which type of admixture is used to improve the durability of concrete in aggressive environments such as marine structure? See, corrosion-inhibiting admixture. The seawater or marine water has this content which is salt, that is salinity. It means chloride ions will be there. That's why chloride ion causing corrosion to our steel or reinforcement is something that we don't want. That's why corrosion-inhibiting admixture should be used in structures, in concrete, which is used for structures that are built in marine environments. Then what is the primary function of shrinkage-reducing admixture in concrete? The answer is it reduces drying shrinkage. Okay, the function of shrinkage-reducing admixture in concrete is to reduce drying shrinkage. Which type of admixture is used to improve the freeze-thaw resistance of concrete? Okay, air-entering admixtures. Okay, it introduces or it creates microscopic air bubble that enhance the freeze-thaw durability. Means in cold countries, in cold climates, we are going to introduce the air entering admixture in the concrete mix. Then what is the purpose of using superplasticizer in concrete? See, to enhance workability without increasing water content, means without changing the water content, we are going to improve the workability of property, right? Then which admixture is commonly used to reduce the heat of hydration in mass concrete placement? Low heat admixture. Either you can use low heat cement, or if the cement or concrete is normal, then you can use the admixture that is low heat admixture. Then how does a plasticizing admixture improve concrete workability? It reduces the water content, right? Plasticizing admixture improve workability by allowing a lower water content while maintaining the workability. Workability is not at all affected. What is the function of a bonding admixture in concrete? See, bonding admixture promotes adhesion between old and new concrete surfaces, right? Now, what is the purpose of using coloring admixture in concrete? To provide a decorative color. Okay, you can use colored cement for that, or you can use a coloring admixture, pigmenting admixture in concrete. And the admixture that is used to reduce the risk of alkali-silica reaction in concrete. And obviously, out of the option, you can select alkali-silica reaction inhibitor. Then what is the primary purpose of using viscosity modifying admixture in concrete? See, The primary purpose is to modify the rheological properties or rheological behavior of concrete. And which admixture is used to improve the pumpability of concrete? Means in order to pump concrete from point A to point B, then we will be using flow enhancing admixture. Okay, means workability is increased without causing any problem of segregation or bleeding. How does self-retarding admixture influence the setting time of concrete? They extend the setting time of concrete. Okay, they delay the setting time in a specific condition. Which admixture can improve the workability of concrete mixture containing low quality aggregate? Superplasticizer enhance the workability even when the aggregate is not of desired quality. Then how can chloride-based admixture contribute to concrete durability? See, they enhance the water resistance. Chloride-based admixture can improve the water resistance and reduce permeability. Thereby, we can use them in marine structure or challenging environment. And since the permeability is reduced, the chances of chloride ion getting inside the concrete structure and corroding the steel or reinforcement get reduced. Then which type of admixture is used to reduce the segregation and bleeding of concrete mixture? Segregation means setting down of content of concrete, that is aggregates are there, fine and coarse aggregates are there, and the layering of concrete is there. And in bleeding, the water comes out to the surface. These problems are called as segregation and bleeding respectively. Then flow enhancing admixture improve the cohesion and flow of concrete, reducing segregation and bleeding problems. What is the function of grouting admixtures in concrete? To improve the flow of grout material. See, grouting admixture improve the flow and penetration of grout material into voids and cracks. Okay, fluidity should be there, then permeating or penetrating properties should be there. That is the function of a grouting admixture. Then which admixture is used to improve the water repellency of a concrete surface? Means waterproofing kind of property. Hydrophobic admixture. Either you can use hydrophobic cement by default, or you are going to add hydrophobic admixture in the concrete, so it will be behaving as a water repellent concrete. And how do high range water reducing admixture differ from regular water reducing admixture? See, they provide greater water reduction with less impact on workability. Then which type of admixture is used to improve the compatibility between concrete and mineral aggregates? The answer is adhesion promoting admixture. Okay, it enhances the bond between aggregate and cement paste. Last question, what is the primary purpose of using expansion admixture in concrete mixture? It induces controlled expansion. Okay, expansion admixture causes controlled expansion in concrete, which is useful for pre-stressing and post-tensioning applications. So that's it for today's video. We will see next 100 quick revision of MCQs in the next video. Till then, take care. Bye bye.